Hello, everyone. Welcome to GDC 2024. Thank you so much for joining us. We have some awesome stuff to show you today. We're all here to talk about how to build successful web games in Unity 2022 LTS. There's a lot of really exciting stuff happening in the web space, and we can't wait to get into it and talk to you about it. I'm Ben Craven. I'm a senior technical product manager at Unity. I run product for the web. And again, this is a time of rapid change in the web space. And we're thrilled to be here and investing in this platform in this critical time. So what problems are we trying to solve? Let's start out with that. First, there's a huge drop in user engagement when creators ask a user to install an application onto their device, whether that be on desktop or mobile. There's tons of studies that validate this. I'm sure you all have experienced it to some degree. So that's number one. Number two, app stores are a huge tax on creators. We have all experienced the 30% cut off the top. We think there needs to be other options, and I'm sure you agree with that as well. So why is the web powerful? It's powerful in many ways, but here's two that I think are especially important for game devs. First, offering content in this way gives players that feeling of instant access as they're taken into an experience with just the click of a link or scan of a QR code. And there's no need to install or ask them to install something onto their device. And second, when you bring your content into the browsers, you have a really direct connection between you and your users, and there's no app store to get in the way. No approval process for patches. It's all a much smoother experience when you can directly connect with your user. So that's some of the broad strokes business opportunity side of things. What about the technical side? Well, on the tech side, Unity Web doesn't have an installation step like other platforms, which that brings the promise of low friction and instant engagement. However, this actually means that users need to download the runtime and starter assets on first load. So for us and for you, the creators, and for all our end users, load time is critical. It's everything on the web. There's a ton of important work being done to reduce load times, and you'll hear more about that on how to reduce load times with Matt from the editor portion of this talk. Now, there's another housekeeping note. The WebGL platform is now known as simply Unity Web. Why are we making this change? First, we want to separate WebGL, the technology, from Unity's web platform. And we also want to prepare for a future with more than one rendering standard, as we'll give you a sneak peek at the future with WebGPU later in this talk. In the future, you'll be able to create a build using WebGL, one with WebGPU, or a single build with both. And if you go to unity.com under the games menu in the platform heading, you can read all about the refreshed Unity web platform. So given those trade-offs I talked about with instant engagement potential, but also having to download starter assets and runtime up front, there are certainly some types of games that work better on the web than others. Here's a couple examples. First, casual and hyper-casual games. They have bite-sized play sessions, easy-to-grasp mechanics. These are perfect for the web because of their small size. The other example here capitalizes on that low-friction nature of the web by taking a small part of a larger game. You could take, say, your tutorial or onboarding level and making a separate web build for that, making that freely available, and basically having that be your frictionless first-time user experience without installing anything onto their device. Then once they complete that level, you can convert them to the native app or wherever else you want your users to go once they convert. These are just two examples, but I'm really looking forward to seeing all the other creative methods creators will think of to harness the potential of interactive content on the web. So we think things are rapidly changing in this space, but there's also a lot of Unity developers who are being successful on the web right now using our currently released LTS. How do they set themselves up for success? Well, first, they optimize for the web. They make sure that end users get the fastest engagement experience with relatively fast load times. And second, they release their games where users will find them. And there's a number of platforms out there to choose from. In fact, one of them, CrazyGames, is here to give you the rundown on their platform and how they've seen devs be successful with web games on their platform. But enough of me blabbing. I'm going to set the scene for Matt to take you through the editor. He's going to walk through our Happy Harvest 2D sample project, how to optimize that for the web. If you are at home and want to follow along, you can go to the asset store, open it in Unity, and try it out yourself.
Hi, everyone. My name is Matthew Buscemi. I'm the engineering manager for the web platform at Unity. Today, I'm going to walk you through the editor and show you specifically in the editor what to do to optimize a web game for Unity 2022 LTS. So this is Happy Harvest pulled up in the editor. You can see I've added some nice little guides over here for us, but down here in our assets and our project, this is Happy Harvest, the whole game right there. So let's first talk about, set the stage. What do we mean when we talk about optimizing a game for the web? Well, as Ben mentioned, the biggest thing that tends to, be a challenge for people when they take their game to the web is that initial load time. So we build a project, we build it to Unity, and we load it up in our browser, and it just takes a really long time to load. So how do we address this? The biggest thing that we want to do to bring down that load time is to bring down the size of two things: the WebAssembly and the data file. Those are the primary components of that build that you get when you build for the web. So what do we do to bring down that size? Let's step through that. So the first thing I want to talk about is asset compression. So the web uses different compression standards than many other platforms. So if you've built a game for standalone or mobile or other platforms, and you've taken your project to the web, you want to go through and make sure that your compression types are set appropriately. I'm going to show you first two ways to do this. Both are useful. The first one is going to seem less useful, but I promise we'll make it clear. So let's head on over to our chicken here in Happy Harvest. And the first thing that we can do is set our compression settings on a one-off basis. So if we go over to platform settings in the inspector here, and we're selected on the web tab, not standalone, but web, we can click override for WebGL. And then we have a selector over here. Many options. The one that we want to use for web is called DXT5. Generally speaking, for desktop web experiences, we want DXT5. The one exception to call out here is ARM Chromebooks. For that one, you'll want ASTC. But most of you are probably going to be going after DXT5. And there are two options for DXT5 here. There's this compressed DXT5, and there's crunched DXT5. In practice, both of these are likely going to turn out about the same for most assets in most games. Crunched gets a little bit smaller, but it's applying an extra level of compression that needs to be decompressed when the game is loaded. So oftentimes what we've seen is that the amount of time taken to uncrunch the files compensates for any time gained by the file size being slightly smaller. So you can experiment with these two options, but probably what you'll want to go after is this compressed one here. Many other options. But now you're probably wondering, this is why I said, hold on this first one. You're probably thinking, Matt, do I have to go through my entire project and set this specific setting for every single asset? The answer is no, you don't have to do that. So if we head over here to our build settings, and in this window, handily at the top here, we can set DXT or ASTC for our entire project, and these will be global settings. So if you don't want to set every single one, you can. But if you want to test, for example, crunched or compressed on particular ones, you can do that too. Moving on from asset compression, let's talk about audio now. Now, art assets tend to be bigger, so we tend to focus on those, but you can get some significant savings with audio as well, and bring down that initial load time. So let's talk about the different kinds of audio that we've got. We typically have two kinds of audio in our games. There are these long background tracks. Let's go pull up one of those here in Happy Harvest. This is the background ambience, some very light birds chirping and things for walking around that farm. The other kinds of sounds are these quick sound effects, very short little bursts of things happening, like this thunder sound effect here. We want to treat these two different ways. So if we go over to our inspector and our web panel here, and we click the override for WebGL, we'll see two things. There's decompress on load and compressed in memory. So the way these behave is decompressed on load. What's going to happen is that the audio file, when the game is loaded, is going to be entirely decompressed and loaded into RAM and available right away. So this is, again, that's an initial load time hit. Something has to be decompressed. Compressed in memory, it leaves it compressed until something in the game says, hey, I need to go play the sound file, and then it gets decompressed and played. The downside to, you might be then say, why can't I just leave everything compressed in memory? The problem with compressed in memory is that, especially for these quick little, you want the Thunder to play right away. If there's even a small gap in that time between when you expect it to play and when it actually plays, because there's decompression, then that might lead to a not so great user experience. So for something like the Thunder, we probably want to decompress that on load. It's small, the hit won't be that big anyway, and it'll be available when we want the Thunder to play. For this background ambience, however, it's a little bit different. So if a background track takes a 10, 20, 30 extra milliseconds to play, probably not a big deal. Also, because it's larger, this is over a minute long, because it's larger, we'll actually get a significant load time savings from leaving it compressed in memory. So we probably want to leave that one alone. So that should about cover audio compression. Next, let's talk about Brotli and gzip. These are compression formats that browsers use for uncoding. The browsers unencode, the servers send these in different encodings so we can save file space over the wire. So when servers send our WebAssembly and our data file down to the browser, we can make those files smaller by applying a level of compression there. Gzip is very, very commonly supported in many browsers. Brotli is less supported and takes some more configuration, but its compression ratio is even better than gzip, so we recommend that. So first, I'll show you the way to set that. If I go to build settings here, and then go over to my player settings, down in the publishing settings under this compression format, we can choose Brotli or gzip or disabled. Disabled will end up with the largest build possible. We've selected Brotli here. But now, as I've mentioned, how do we get our web browser to actually serve these files correctly if like gzip, it isn't supported out of the box? I'm going to pull up Visual Studio Code here. And so here is a configuration file for a locally running Nginx server. And as you can see, I've added these sections that allow the data JSON file, all the JavaScript files, and the WebAssembly with the Brotli type attached to them. We're going to do two things. We're going to make sure gzip doesn't get applied on top of Brotli. That would not be good. And then we're going to make sure that the correct headers get sent to the browser so that the browser knows to decompress with Brotli. Once we do this, we can see that Happy Harvest running locally serves correctly off of Nginx, and we can walk around in the game and explore the Happy Harvest farm as we desire. So, heading over to settings. Now, there are a lot of Unity settings, I know. I'll go through them. I'll show you which ones to pick out to really make sure that we bring that size of your WebAssembly files down as much as we possibly can to achieve the shortest download time possible. So we're going to go back. The first one is right on this build settings screen right here. By default, short build time is probably selected. This is likely what you'll want to use for development builds or builds used for testing, because these other options, while they lead to a much smaller build, take quite a bit longer. But when you're ready to make those really, really optimized builds for serving over a web server to players, you'll want to select this disk size with LTO. This is the one that will lead to the smallest build possible. LTO is link time optimization. This is going to go through and really make sure that we're stripping out as much code as we possibly can to make that final build as small as possible. Over in player settings, I'm going to start in the player section here. We've got WebGL selected in the group, and we're going to start in other settings. The first one to pay attention to is this API compatibility level. .NET Standard 2.1 is going to lead to a smaller build than .NET Framework. IL to CPP code generation should be changed from faster runtime to faster, smaller builds. Should be evident why. And down under optimization, there are a number of things to check. We want to strip engine code, clearly. We want to set this managed stripping level as high as we possibly can. I say possibly can, you'll want to test your build. If you get runtime errors or something about this stripping is stripping too much, you'll have to dial it back. But as general practice, you want to set this as high as you possibly can to get the smallest possible build. In Happy Harvest, there is no need for me to select optimize mesh data. It's not a 3D game. There are no meshes. But if you do have a 3D game, you'll definitely want to make sure that this is checked so that we optimize those meshes as much as we possibly can. Under publishing settings, this is where Brotli and gzip were that I talked about before. We want to make sure that data caching is checked. This will make it possible to reuse things that have been data and specifically pieces of our game that have been cached so we don't have to re-download them. Debug symbols when we're producing one of the builds for our players should be off. Not only does this make it significantly smaller, but just a general best practice that will also improve load time, however. And finally, if we head to the graphics section, there are a number of important things to note here. So these shaders have come in by default with a Unity project, and for most platforms, this is great. On the web, like I said, we're stripping out everything that we don't need as much as we possibly can. So we want to go ahead and for Happy Harvest, I can zero this out. These can all be eliminated for this project. Another thing to take a look at here are these light map and fog modes. Changing either of these to custom will give you tick box selectors of which of these that you can turn off and therefore exclude from your game. Happy Harvest doesn't use any of these, so you can safely tick all of these off and the Happy Harvest will build just fine. You can also use the current scene as a basis for determining whether or not your game uses these things. But again, this will only look at the current scene. So if your game has many scenes, you'll have to go through and analyze each of those. But in general, you want to make sure that as many of these are unticked as you possibly can. And then, of course, once again, it's the same thing for the fog modes here. You should go through and check those as well. So that should about cover it for the settings. Next, I want to talk about packages. If you have a project that you started on another platform, you probably just imported packages as you needed functionality. This is Happy Harvest. This only uses core Unity packages, but in a project like we see from many people, there are just lots of different packages here. Some of them start to be used, some of them stop getting used later, were replaced with others. And now that we're on web, it's a good time to go through and make sure we need all of those. Now, if you're not using that package in code, yes, the compiler will strip it out, but since that load time is so important for us on web, we want to just make sure anything we're not using that we cut it out anyway. So going through and doing an audit here is a really good idea. More important than things you're not using is to also look at each thing critically with the eye of, okay, we need this package. We need some functionality here, but do we need the whole package? A great example of this is Newtonsoft, which many people use exclusively for JSON serialization and deserialization. Newtonsoft is a great package with lots and lots of really great functionality, but If all you need is JSON serialization and deserialization, Unity's JSON utility is much, much smaller and can achieve the same thing. So this is an example of where you can take out a very large package, which is going to increase that download time by a lot, and replace it with something much, much smaller. So go through each of your packages and do this exercise for each of them. Next, I want to talk about deferred asset loading. So on many other platforms, we don't quite think as much about how long things take to download. It's just not as much of a concern. But here it is. And so if you have a project that's coming from another platform, you probably just have a really big assets folder, and we just put assets there. By default, what this is going to do is load all of those assets at the start of your game. So your game is going to sit there loading assets, and the player has to wait for everything in the game to be loaded before the game can start. And so we want to change this for the web. We want to do something a little different. We want to load only the assets that we need for that very, very first scene. And then the moment the player hits it, begin downloading all the other assets for the game after they start, so that they can get into the game as soon as possible. In order to achieve this, we need one of two systems in Unity, either the older asset bundle system or the newer addressable system. So addressables is the suggestion here. And you can see this, I've pulled it up in the Unity registry of the package manager here, which can be installed. Now, implementing deferred asset loading with this addressables package that I've described here is well beyond the scope of this 15-minute presentation. I've included the link to the Unity docs describing how to do this in the notes accompanying this presentation. So please refer to those if you have any questions. Next, I want to move on to talk about preload tags. So we've talked a lot about what to do in Unity to optimize a game, but there are some things that can cause your game to slow down even after they hit the browser and decompress and Brotli and all that stuff. They can be slowed down by other things. What are those other things? Well, for example, let's head on over to this browser, and we can see, I'll do a refresh just to be clear. Oh, hey, this is interesting. So here's the load of the page, and here's where the icon and the static images have gotten downloaded. But then something has forced some kind of 200 millisecond delay before the game ever even begins downloading. How did this happen? Well, let's go look at the code. Oh, look, someone put a 200 millisecond delay into the page before we can ever start loading Unity. And this one is a silly set timeout, but this is simulating a real thing that happens where, for whatever reason, there's a platform or a site that needs to load some kind of JavaScript or CSS or some other dependency, and they don't want anything else to happen on that page until that library becomes loaded. And so there's this artificial delay before we even begin downloading the stuff we need to download to play the game. What are we supposed to do? Because, I mean, in this particular example, I mean, sure, I could take out the set timeout, but if that's a dependency of the platform we're on, we can't just take it out. So how do we solve the situation? The answer is preload tags. And so in this example, I've taken the same HTML as before, still got the 200 millisecond timeout, but I've added these preload tags at the top here. And so this is the data file and the WebAssembly and the JavaScript dependencies. And what these tags are going to tell the browsers, hey, I don't care that you haven't gotten a request to download these things yet. Just start downloading them now. And so if we head back over to Chrome and we look at this version, we see something very different. And so here's where our page is loaded. Here's where all of the static assets begin downloading. And you can see the WebAssembly and the data file begin downloading at exactly the same time. When we get to 200 milliseconds later, the browser doesn't start downloading new copies. It just picks up the ones that have been preloaded and carries on forward. So we've managed to get loaded here, and it looks like about 320 milliseconds on this one. And here we went up to about 380, 390. So I know you're thinking maybe 40 to 70 milliseconds isn't that big a deal. But remember that I'm running on local web servers for this presentation. And so in higher latency environments, these effects are going to be magnified. So you could see yourself saving as much as half to a second of load time just by implementing the strategy, if there is something that is blocking your WebAssembly from starting to download. So that is everything that I wanted to show you today about optimizing a game for Unity 2022 LTS. Thank you very much. And next, I'm going to turn it over to Raphael, who's going to tell us all about monetization of web games on CrazyGames web platform. Thank you.
Good evening, everyone. I'm thrilled to share the stage with my friends from Unity and talk about how you can be successful on the web with CrazyGames. But before that, let me share a personal note. I've been working in the web gaming space for more than 10 years. And I think we're living the best time for web games. And why do I think that? Well, as the VP of Marketing Partnerships at CrazyGames, I have the privilege to talk to all folks in the industry, from game engines like Unity to publishers and developers and service providers. And I can tell you that the web is a hot topic. New trends like web GPU, the cross-platform publishing, and increasing pressure of the app stores are building the perfect store for the web games. So what is CrazyGames? As you may have guessed, CrazyGames is a web gaming platform where people can play your games with a single click. There's no installations, and they can share easily a link with a friend and play together. With a community of more than 30 million monthly active users and more than 1,000 Unity games, we are one of the biggest catalogs of published and monetized WebGL games on the web. At CrazyGames, we're proud to work with all types of developers, from students to indie devs to large mobile publishers like CrazyGames, Bombit, and Supercent. We have a community of over 2,000 game devs. Well, we're bringing here some successful games to highlight. One that I'm very proud to show is Squad Blast, a game developed by Ultra Horse. It's very high hit rated on CrazyGames. They have a lot of plays, and this game is what I think is really nice. I'm talking about cross-platform publishing, is that this game is available on consoles, on PC, and also on the web with CrazyGames. We help them populate their service with many great web players, and so people can quickly find a matchmaking across all the platforms. Well, we couldn't agree more with what they say about the Unity. We're very proud to work with them, and also very proud that to publish this game on CrazyGames. And together with Unity, CrazyGames, and Ultra Horse, we think this a match made in happen. Another great showcase that we have on the platform is Turbo Stars, made by CrazyGames. This game was originally published on mobile, and it became a success, a massive hit on the web with CrazyGames. With millions of players, extremely high rated game, and a lot of gameplays, our community loves this type of games. But it's not only about the big guys. We also have a lot of indie teams or sometimes solo devs and students that publish game with us. One important part about CrazyGames is the monetization side, right? Like we work over the past years improving what the toolkits that we offer for developers. As many of you might know, historically, a lot of the monetization of the web happens over advertisement, and we offer a very easy to use SDK. We're gonna take a look at this in a second. And there we have like rewarded videos, interstitials, everything that it's available for you. We also offer banners and in-app purchase, and we're seeing also great results with in-app purchase on the web. Some games are able to add an additional layer of revenue up to 100% on top of what they're making with ads. You can find all the information for our documentation on the link on the blue link, developers.crazygames.com. It's very lean, very easy to use. In terms of ads and banners, we have a really straightforward process. You can just drag and drop things, and simply works. So you can really focus on what you do best, which is developing the games, right? And for banners, it's exactly the same. Well, it's very easy to use. You just grab and drop and put it in your project, and you can test this as we advance. Uploading a game on CrazyGames is rather straightforward. You first give some game description, you put some tags, some basic information about your games, and you let us know if we should save the progress from your game or if you're doing it by yourself. And we can sync this with the user profile that we have. In the last stage, you upload some cover arts, you accept the distribution terms, and you submit the game for review. But before you submit for the game for review, we also offer QA tool where you can test and see if the advertisements are working, if everything into place and working correctly for your game. Once you test it and see everything's fine, you submit your game for review. And our QA team will receive your submission, will take a look. They will get back to you with valuable feedback, giving tips and suggestions, and also testing your game with several devices. So we make sure that the experience is bulletproof and you're set for success. On top of that, we also offer the WebGL Optimizer, which will soon be rebranded for Unity Web Optimizer, I believe, where you can download this on the Unity Asset Store, but it's also integrated into our SDK, and it will help you with compression and also optimization for your game. So that's it. Working with CrazyGames, it's very easy. We have a very supportive team, and we're waiting for your contact. So let's make a great game together, and you can ping me here or just write me directly. Thank you.
Thanks, Rafael. So we've talked about what you can do now to be successful on the web. Let's dig into what's coming next. And there's a lot of exciting stuff on the way. First is WebGPU. So this is a new rendering backend for the web, and it marks a significant milestone for web-based graphics acceleration. This will lead the way to unprecedented leaps in graphics rendering fidelity for Unity web games. We're really, really excited to share it with you. WebGPU is designed with the goal of harnessing and exposing modern GPU capabilities on the web. This API achieves this by providing a modern graphics acceleration interface that is implemented internally via native GPU APIs, such as DirectX 12, Vulkan, or Metal, depending on the device you use. WebGPU will unlock support for new and exciting rendering features as well, and enable levels of graphics fidelity previously unseen on the web. Similar to other modern graphics APIs, lower-level control over the rendering setup and GPU execution unlocks new optimization opportunities as well, and that could lead to reduced CPU and GPU overhead and improved throughput latency. So not only are you getting modern rendering techniques and features, but this could actually lead to better performance and lower overhead as well, which is really cool. WebGPU brings compute shaders to the web for the first time. This is huge. Compute shaders are becoming a critical part of modern game rendering. We're really excited that this is coming to the web. It makes us more of a peer platform with things like console and desktop and mobile, native mobile. The other thing, in addition to compute shaders, well, as part of compute shaders, you get compute skinning, which radically improves the performance of rendered skin mesh characters. So now all those vertex transformations are offloaded from the CPU to the GPU. This is radically different performance, as you'll see in a moment with a demo we'll show you. Another new feature that you get with WebGPU is Unity's VFX graph, which procedurally generates geometry directly within compute shaders. And that's super cool as well. So speaking of cool stuff, let's look at some demos. So first up, we have Bodatech. This is one that you may have seen. It's a few years old, but here it is running in WebGPU on this MacBook Pro. As you can see, it's running super smooth, capped out max frame rate basically, and it looks fantastic. And here we have our GPU skinning demo, where you have this Unity Atom asset. What we did was we duplicated the asset a bunch of times. We added some light VFX, and we're doing all the GPU, or we're doing all of the vertex transformations on the GPU. This demo, when it's running in WebGL with CPU skinning, runs at about 5 frames per second. And on WebGPU, you can see the performance is great. It's actually perfect. And finally, we have our VFX graph teaser demo. Now, this demo is made with 500,000 individual particles, all being rendered to create these beautiful logos in real time. We have the WebGPU logo, and we have the Chrome logo, as we're working closely with the Chrome team at Google on our WebGPU implementation, the Unity logo, and I can even move around the camera to prove this is all real time, and it looks fantastic. So WebGPU is enabled today on Google Chrome and Microsoft Edge on Mac OS and Windows. Through our development of Unity's backend for WebGPU, like I mentioned, we've been working closely with the Chrome team at Google to stress test WebGPU with large scenes and complex shaders, and we've seen some fantastic results. Unity's WebGPU graphics backend is still in development, and we do not recommend using it for production use cases. However, early access to the backend is available today in Unity 6 beta. So if you're into experimenting, go check that out. There's details for how to get access in a linked forum post on the web forum, and we can't wait to see what you create with WebGPU. So earlier, I've been talking about changes and a lot of exciting things happening in the web ecosystem space. One of the things that's changing is the rapid deconstruction of mobile walled gardens. We've heard plenty of feedback about this, and actually there's a lot of feedback about this. These are all real customer asks from just 1 month, actually, directly to me. And we were super happy to announce that Unity 6 supports mobile web browsers for the first time. So what does that mean? It means creators can run their Unity games anywhere the web exists, including in iOS or Android browsers themselves, embedded in a web view in a native app, or using a progressive web app template to make your game behave more like a native app with its own shortcut on the home screen. We're confident developers targeting web on mobile will have success with high-end mobile devices released in the last 2 to 3 years, but this will vary quite a bit, obviously, based on your content. By the time we ship Unity 6, we will have clear guidance around the min spec for web on mobile. But here you can see our recent 2D sample project, Happy Harvest, that Matt talked about, running in Safari on my iPhone 15 Pro. Also, you may have heard we've partnered with Meta to build support for their instant game platforms. This is where users can find and play games instantly on Facebook and inside Messenger conversations. There's an audience of hundreds of millions with Meta Instant Games, and it's a fantastic new platform opportunity for Unity devs to extend their content's reach to a whole new cohort. There are a number of things we're doing to facilitate this partnership, including a dedicated build target, a C# SDK, a multitude of net new optimizations to ensure users can get into games in seconds. These tools are results of our direct partnership with Meta, but they will be available to any Unity creator who wants to bring their projects to the web. We are also partnering with game studios to prove out and validate this new tooling as launch partners. If you have a game that you think would be a good fit for this, please do contact me or come onto the forums or look at our website. We have a sign-up form to indicate your interest. And whether you're publishing with our friends at CrazyGames, Facebook, Messenger, or somewhere else, there's a ton of opportunity out there for web games, and the opportunity is only growing right now. So to reiterate, mobile web starts in Unity 6. If you like jumping in and trying the latest technology to see where we're headed, go read our forum post about WebGPU, which is available now in Unity 6 beta. And coming late this year, you can build and deploy your instant games to Facebook and Messenger to access a whole new audience. And that's our presentation. Thank you so much for taking the time to watch this. If you scan this QR code, you'll be brought to a landing page that will tell you more about our revamped web platform, how you can get involved in our instant game launch partner program, and more. Thanks again, and I look forward to seeing what you create on the web.